So, good morning, everyone. Welcome to the second day of our fourth tutorial. And this tutorial is on getting started with Nomad Oasis. I guess you were all here yesterday when Claudia gave her overview talk about the FAIRmat project and what we want to do with the Nomad software in there. And I gave a little bit the theory part of this tutorial where we were talking about how Nomad works, what components there are, how these schemas work, and so on and so forth. And today is I guess, the more exciting part, where stuff gets practical. And I want to show you a few things. I split this into three parts. First, we will look at the installation of the Nomad Oasis. And then there's something on how to write schemas for ELNs. And then we have also something for tabular data. It's really hard for me to look at the chat and answer your questions during the thing, right? Because I have to focus a little bit on what I'm typing, what I'm doing. So I will break after each of these three sections, and then we can have a little bit of a Q&A and answer questions and stuff like this there. Yeah, so I guess we just jump in and start with the installation part. What I've prepared here is just, yeah, I mean, you can download these slides from the tutorial page, right? This is, okay, put them here. And you will find a few links in here, but yeah, it's just informational. The only thing that you actually need to know is like what our homepage is, like this nomadlab.eu, and you will find all the relevant links here. So today we want to look at the version 1.1, which we currently have in this beta kind of status. So when you click here, you basically get to this version. It tells you you are on the beta version and blah, blah, blah. And the thing is, like, whenever you want to look at Nomad documentation, for example, let's say for the installation of the Oasis, the documentation is also linked to the various versions, right? So when you are on this version 1.1 thing and you click documentation here, then you get the documentation for the actual version. And especially for the Nomad installation, we changed it quite a bit. We tried to make it much easier. So it's worth looking at the new documentation for this. So this is our documentation side. And I guess the interesting parts for today is like operating on Nomad Oasis. And then later, when we look into schemas and stuff like this, we will look at how our archive, our data format, and how the meter info, our schema format is working. So for the Nomad Oasis, it's a lengthy kind of document that contains all kinds of information, but we start with a very simple quick start thing where we boil the installation down to a few shell commands. So that's the first thing that we are going to try. And then we look a little bit at the config files and maybe I explain a few things there. And then we can also look inside of the containers and try a few like administrative commands, like a few tricks that might be helpful in actually maintaining the Oasis. So, but let's start with the very simple stuff. So what you need to have is like Docker and Docker Compose. So I prepared here just a little tool here where I can have a terminal. So I don't have much in here. I just have like one kind of file that I need to delete for some demonstration purposes, but otherwise I don't have anything in here. My Docker is completely empty. So yeah, it's somewhat a clean slate. So so what we can do now is like simply download the basic configuration. So let me click on this and then just download this to my to the folder here that I'm working in. So now let's go back. So now I have the downloaded file here. I simply unzip it. That's the wrong command. So okay, and then we get this folder here, and then there's the three configuration files that are necessary. The first one is the Docker Compose that basically contains the configuration on which Docker containers to start and how to connect them. And here you find the different components that we talked yesterday that we need to start. There's this RabbitMQ. This is like our distributed task queue that we use to like register all the processing tasks, and then the worker can pick up on them. We have the Elasticsearch that's here and the MongoDB. And they are all pretty similar. They just take the standard image that these projects are providing. We name everything Nomad Oasis _ something so that you can find it among other containers you might have run on the system. And then they typically just have volumes declared where they can store whatever they need in terms of, like, most of them are databases where they need some storage to put in their information. So for the RabbitMQ, for the Elasticsearch, and for the MongoDB, it's basically the same. For the MongoDB, we also prepared here like a host mounting to our volumes directory. We can talk about this later, where we can put in Mongo backups and stuff like this. So, and then we have the actual Nomad processes or container. There's the worker container, there's the app container, and there's the North related thing, but we are not going into details about this today. And then there's a GUI container that basically binds all the various apps together and provides everything behind one proxy. Okay, let's look a little bit at the configuration of each of the Nomad things. Also pretty basic. We are using like our image that we have on our GitLab. So this is like publicly accessible. You can just use this as an image name, and then Docker can pull it from our GitLab site at npcdf. And these are the tags that I talked about yesterday that we use to control which version and which flavor of the scheme of the image that you are getting. So right now we're using the version 1.1. Yeah, but you can also use the latest tag, for example, to get the latest development version and so on. Otherwise, it's pretty straightforward, I would say. These kind of links are necessary to connect our Nomad thingies so that they can talk to the databases. In terms of volumes, we mount our configuration file, this Nomad YAML here, into the container so that the container gets to the configuration. And then we also mount the volumes thing into the container. And this is then where all the files get stored and where we are working with the file storage of the host system. And then this is the command that starts the worker. We use the same image for the worker, the app, and so on. So these commands are different. Like for the worker, we start the worker. For the app, we start the app, and so on and so forth. So the app, it looks very similar. It's the same thing. We just start a different command. Let's ignore the Jupyter Hub for now. And then the GUI just runs an Nginx that serves as a reverse proxy. So when the users are going to your Oasis, they're actually going to this Nginx server, and from there they are redirected to the app or to whatever is necessary, depending on where they currently are in the Nomad application. And I think the only thing to mention here is that we here have bind this to a host port. So we just bind this to port 80, and then we can basically access the Oasis like a normal web server. And then if you want to integrate this into your larger infrastructure, you can have different proxies in front of this and then forward to this one, and so on and so forth. So you don't necessarily have to run this on 80. You can run this on any port that you configure here. Yeah, and that's basically it. That is necessary in here. Then we have the Nomad YAML, which is the main configuration file for the Nomad itself. It's also pretty short, I would say. We basically have to define on which host we are. This is like important when we send URLs to the user that he knows how to get back. So if you run this on a proper setting where you have like a server with a certain host name, you have to put it in here. You can change the base path of the application if you want to run multiple applications on the same server and stuff like this. That might be necessary to change this. Then otherwise, we say that we have an Oasis and that we want to use the central user management. We can ignore this for now. And yeah, the rest is just telling a little bit. You can give a name to your Oasis and stuff like this. You can put in your maintainer email. This will become important later when we actually make a connection between the different Oases and where you can then put stuff to the central system and things like this, so that we get some provenance information, like what is this Oasis, where the data is coming from, what it's called, and so on and so forth. But right now it's not really functional, so you can also ignore it, I guess. And then we set the names in MongoDB and Elasticsearch. So that might be interesting if you want to run multiple Oasis on the same MongoDB, the same Elastic or whatever. And you can configure names here, but usually you can just leave it as the defaults. So you don't have to change much. Like, I guess the only things that you might want to change are those depending on where you want to run this. And then we have the configuration for the proxy. So these are just rules that we need. I don't want to get into them into much detail. The only thing is, like, if you want to change the path, the base path, you also have to change it here in these 3 places. But otherwise, I guess you can ignore this. I guess that this will become interesting for you if you want to put another proxy in front of it to a little bit look at the rules and see what's happening here. But it's not really anything magical. It's also like rather short, I would say. Okay, so these are the technical aspects. Now let's try to actually start this. So with Docker Compose, there's like this Docker Compose command run, right? And the first thing that we need to do is to pull all the images that are referred to in the Docker Compose file. I have forgotten to switch the folders. Of course, I have to go into there. So I'll try it again. And now it's basically pulling all the images. So typically this takes much longer than what it did right now. It's just because I already pulled it before, so the images are already on my system. But this might take a few minutes to download everything and whatever. So now the images are there, and now you can simply run everything. So if everything runs smoothly, you don't have to do much. You just say Docker Compose up, and it starts all the containers. With the -d flag, you can run them in the background. So let's try this. So it gives you a little bit of a prompt that it's starting all the containers. So now in principle, the containers are running, but they're still like initializing and whatnot. So one thing that you can do is you can simply try to poke for the server whether it's ready or not. So we have this little alive endpoints in our API that you can use. So once the server is ready, you should get a response here from the alive system, and then you know, okay, everything is up. If you are on a slow system, so currently I'm not really sure what's happening with like Zoom running at the same time and whatnot. You might run into a timeout here. Like if this runs longer than a minute or something, you will get a timeout and just try it again. But typically it should start in like, I don't know, 30 seconds, 40 seconds, something like this. So let's take a few seconds and wait. Yeah, okay, now it's basically started. So this is when everything goes right. We later can also have a look what can you do when stuff doesn't go right, when you wait for 10 minutes and nothing is happening. But right now everything worked. So let's have a look at the Oasis. So with this basic configuration, we are just running this on localhost. So if I open a new tab and just go to the Nomad Oasis thing here, something should start. Right, and then this is the Nomad Oasis that we just started, the normal about page that you get. I'm already logged in. It's the same user management that we use on the central system. So if you are logged in, you are logged in. And otherwise, it looks pretty much the same as the normal Nomad. The only difference is now we have like this Oasis logo, so that you get an idea. Okay, now I'm not at the official site. I'm now at my own place. In the future, maybe this will diverge even more, so that the Oasis gets some functionality that the central system has not, and otherwise, and the other way around. But right now, it's basically pretty much the same thing. Yeah, so this is everything that is to it when everything works smoothly. Maybe a few things what happens when stuff goes wrong. So let's say this didn't happen for you, and you waited for a couple of minutes and you retried this alive thingy and nothing really happens. One thing that you can always do, of course, like you can see what Docker is actually running, right? So you have the ps command to see what containers are running. And here you then also see, it's a little bit broken because my terminal isn't wide enough, but if you look at the table, the container have names, right? So we named everything Nomad Oasis _. And then you can use this, for example, to look at the logs to see whether there are some errors or whatever, right? So you can use the Docker log command. For example, one thing that is often giving people trouble is Elasticsearch. So you can can have a look at the logs and see if there are any errors or whatever. Like, and typically when you see errors and then do a little bit of Googling, you get these problems sorted out. I mean, Docker, Mongo, and whatever, they put some efforts into their Docker setup, and typically it works pretty well out of the box. So yeah, that's one thing that you can do. You can look at the logs of the various containers. Maybe you also have a graphical tool or whatever. On macOS, there's like this Docker client where you can actually click and see stuff. But But of course, the command line is always available everywhere. So that's one thing to get troubleshooted, right? To look at the error logs and see what you can do there. When you see errors in the logs of let's say the Nomad Oasis app or something, like in our containers, we have to say logs. Right, so this is what it typically should look like. If it's not looking like this, then there might be problems. So when you feel that the problem is on the Nomad side and that you want to report a bug or ask a question or whatever, I put links to our forum into the slide, so that's one way of going, or you write us an email, so that's the other way of going about it. But it would be interesting when you have troubles with starting this, that you always send us the Docker Compose file and the Nomad YAML that you have, so that we can have a chance to reproduce the error somewhat. If you just send us a screenshot of the web app saying something is not working, then it's typically not really helpful. So we really need to look at the details here. And maybe you also want to attach these logs that you get from the containers so that we have an idea what's going wrong. Yeah, otherwise, we can have a look at the volumes thingy that was created. So you saw in the Docker Compose file that we have these mount points where we go for the volumes directory, right? And this is this one here that got then automatically created when we started the Oasis. And here we basically have this one folder where we store all the data that is in the Nomad Oasis. Like later in the tutorial, we will see when we actually create data, how to find it here, right? And these folders might get actual subfolders, and then you can see the user data and whatnot. So this is where all the data is being kept. And the Mongo one is currently empty because we didn't really run any backup or dumps of the Mongo database, but this is where they would end up. So this is like a common question. What can you do to back up the system, right? So this is like all the information that's basically necessary. Like 99% of the data that you are accumulating with your Oasis will be in this file structure here. And if you have this file structure, you can basically reproduce most of the information that's necessary. The only missing part is the MongoDB. So if you want to set up a proper backup, you can go to our documentation. We have written a little bit about it here. But basically, you can go into the Mongo container and run a backup there, and this will basically back up the Mongo database into this backup folder. If you do a cron job around this, do this nightly or whatever, and then have an rsync or whatever kind of backup strategy for the volumes folder, then you should basically be safe and have everything together. And then there are commands, of course, to restore the backup once like something went wrong and you have to set up your new Oasis or whatever. You can use these commands to reinstate the Mongo backup. And then one thing that is necessary is then you need to rebuild the Elasticsearch index, and there's also a command for this. And speaking about these commands here, that's another thing that I wanted to show you is like for most administrative stuff, you can work with the normal command that we provide that helps you to look at uploads, to like stop processing of stuck uploads or delete uploads, or when something goes wrong, reset everything, like these kind of things. And to do this, you can basically open a shell in one of the containers. Like typically the app container is a good choice. So let's open a shell there. And I always forget to make this interactive. So now you basically get a shell. And so you are in the container right now, right? So this is what our image looks like. All the Nomad files are there and so on and so forth. And as part of the of this, you get the Nomad command. That's basically a command line utility, like a command line client into the server and other functionality that you can use to control some aspects of Nomad. So, and the most interesting one, I guess, is the admin command. That has a few things where you, like the reset command is something that is frequently used when you really want to wipe the whole installation. You can run this one and remove all files, everything from the database and whatnot, and basically get a fresh install. I guess especially in the tryout period, that's something that you might want to do from time to time. And the other interesting one is the uploads command, which basically acts a little bit like yeah, you have a list command to see all your uploads. You have a rm command to delete uploads. You have an index command to re-index all uploads. You have a process command to reprocess all uploads. You can use this for some maintenance stuff. If something gets stuck, you can use this to delete an upload, for example. Yeah, we can later have a look back here when we have some actual data to work with, and then look at some of these commands here. Right now the Oasis is empty, so it's kind of boring. Yeah, but in principle you can also use this to then delete uploads, and then you can type an upload ID that you get from the UI or whatever to delete an upload, for example. Yeah, that's basically it. I think yesterday there was the question if there's a possibility to create a whitelist so that not everybody can have access to the ACES. So right now it's like this, right? You just run a server, and in principle, when you expose the server to the internet or whatever, everyone could go there, and like if they have a Nomad account, they can start uploading stuff and whatnot, or look at the public data in the system. So if you don't want to have this, there is this way of whitelisting. I hope that we have documented it somewhere. Maybe restrict. Yeah, here there's like something in the Oasis that tells you how to do this, right? So in your Nomad YAML, you can simply put a list of allowed users and then have a list of email addresses of that has to be the email address that they use to register their Nomad accounts. And then you can create a whitelist like this. So in the Nomad YAML, you basically have to in the Oasis section here, you can have this allowed users, right? And then you can have your whitelist of users. Yeah, if you need to update your Nomad Oasis, typically the only thing that you have to do is to change like the version tag. Or if you are on the latest tag and you know that we changed the latest tag to a different image, you just have to pull it again. Like Docker Compose will basically realize, okay, it's the same tag, but it's now a different hash and whatever, and will pull the new image. And then you have to restart your Oasis. So, and this is like in Docker Compose. Like if you're familiar with it, it's not really, you say Docker down, it basically removes all the containers, and then you say Docker up again, and then it restarts everything with the new image, and then this should be it. Otherwise, if there's something to migrate in terms of the databases or whatnot, we will announce this, and this typically only happens when we change the major versions, and hopefully it won't happen frequently. Yeah, so that's basically what I have to say, and now I'm interested if you have questions to this. So now I can pay attention to the chat and everything. Let me see. I think there's already something in there. Which Docker Compose version is necessary since I get network default value, additional properties are not allowed, name was unexpected. That was a question from Thomas. I have no idea what I have in here, to be honest. Like the Docker Compose, I think you have to distinguish between the Docker Compose file version, right? This is what we state here. And then my assumption was that even newer Docker versions can actually deal with this and have some compatibility for this, right? Basically reading that this is not version 4 or whatever, and knowing what to do. So I guess your Docker version has to be at least 3.4, but I'm not sure. We can try to have a look into this. Can you tell me what Docker versions you have? And then maybe we can have a look into this. Because I can show you what Docker Compose version I have here now. Let me see. But is this the warning, or is this really an error that is coming? I have to, Lucia, can we allow everyone to unmute by themselves? Because otherwise I always have to click stuff that's for the discussion, not really helpful. Oh, that's unfortunate. So everyone has a new Docker Compose, and I'm running my super old Docker Compose, I guess. Let me see. Just to confirm, like I'm running whatever this means, right? This version number here. And now I will try to find a way so that you can all be allow participants to unmute yourself. So you should be able to unmute yourselves if you want to talk. So, okay, so you have version 2, right? Interesting. So then I guess we really have to look into this. So that's a big blunder. I wasn't really aware that.
Markus,
Yeah.
So the version that had the problem was 1.25, but I typed I have 2.4.1 and it works fine. So I remember I had to update my Docker Compose. So I guess it's
Okay.
it happens somewhere between 1.25 and 1.29.
So it works with all newer versions and
Yes.
older versions, but not when you have versions in a weird spot.
Could
Okay. Interesting. But what is it complaining about? Like maybe we can just remove something from the Docker Compose so that's not super. Maybe someone wants to try this.
It was the network name.
The network name.
Yeah, but I think you're using that somewhere because
I guess it's this one, right? But I guess you can live without it. Like then if it just gives the default name, yeah, and you don't want to run the hub anyways, I think you can just comment out the last 3 lines and it should still work for you. So for those of you that have like this problem where the Docker Compose is not accepting the YAML due to something in the versions, just remove this and try it without this. Because it's not really necessary, you can just use the default network name. We don't have to set the name explicitly. It was only necessary for this part of the application. So let's say we ignore this for now. Then that should still work. Okay, great. So someone has made a polling without these last 3 lines. Yeah, I don't think they would cause any problems, the missing lines. So just try it without these. And then we try to put it in the documentation that there's a Docker version span where this problem might appear. Okay, so that was the first exciting part of the session where something unexpected happened. So let me see if you had other questions as well. But I guess most of the questions were about this. To be honest, I have no idea what the relationship between the Docker Compose releases, like 1 point whatever, and the version, Docker Compose file version, what the relationship is. Because the Docker Compose versions, like having 2 point something, and the Docker file version being 3.4, that's seems to be unrelated. I don't know how Docker Compose organizes this for themselves. Okay. So if there are no questions, and I guess you're already trying this kind of stuff, the idea is that we have another session in the afternoon as well. It's like if you want to try this in between, because otherwise I would continue with the tutorial and go for the other parts. But of course you can still accumulate questions for this, and we can also answer them after the next part of this session. Okay, then I will go on and go to the next part of this tutorial. Let me restore everything to its old condition. Okay, so now I have my Oasis running here. This one, and now we want to do something with it, right? So at the very beginning, when you go to, I don't know, the explore section, for example, nothing is in there, like it's empty. Or if you go to your uploads, like your user space, so to speak, like for me, it's also empty, right? It's a completely empty Oasis. So what we've done to help you a little bit initially is we created this example uploads thing here. So you basically get a choice from a few examples. We want to refine them, and later there will be like more real examples. At the moment, they're more technical and then super small. So it's just to demonstrate the basic stuff. So they're more like tutorials, not really actual examples of actual experiments or whatever. Yeah, but again, in the future, we might expand on this and then also provide like more real examples, so to speak. Right now, these are pretty basic. Tailored at different use cases. So we have one example for the typical Nomad use case where you have electronic structure codes data. We have one example for a lab notebook. This is where we want to look at later, and then also tabular data, where we also want to have a look in this tutorial. So you have this on all the OASIS that run version 1.1. And you can also do this on our public system. So if you're here on the new beta version, and go to uploads, you get the same thing. Like here, I already have lots of uploads. Like this is like really the central Nomad and stuff like this, but I can still add something here. So for example, I could add the electronic structure code input and output files example. Here, I just press the add button. Then it basically creates a new upload and uploads this example data automatically. So you just have to wait a little bit for the processing to start, and then these entries that are uploaded, they appear here, and you see the processing is still running for some of those. And then at some point, when everything is finished, this thingy here will go away. Yeah, but then you can have a look at like how the typical Nomad data works, right? And that, I guess, it's also a good test for the OASIS, like running one of these examples, just to see if everything is in there. And then, like, if you you saw this in the first tutorial of the series, you can also go back to the videos for explanations on what these views mean and what the data is about. Yeah, so that's the first example. By now, it's also finished processing. We put a little README on these examples to explain a little bit what these examples are about. But I guess this becomes more interesting in the future when we have more complex examples and so on and so forth. Yeah, otherwise you can see, browse the files that were uploaded and so on and so forth. So that's for the theory example, where we just uploaded like the typical like simulation data, how people typically do it, like everything in its own directory and blah, blah, blah. And then you see like here, you get the entries. These are then the main files, right? These are the files that our parsers detected, and then where we created database entries from, and then you can go there. Yeah, typically you always have this view where you can browse the files. And you also have this view where you can see all the detected files, right? Here you see the file names, and then some metadata that we got out of the system through processing, and then you can also go to the various entries that we have for these things. Yeah. We also have like this new file browser that you can use to go through the files. Like if you have more complex uploads and stuff like this, that can be very helpful. And then you can also add data and download the data and whatnot. So it's just a bare bones example, but it tests a few things, right? If you run this in OASIS, you are clear that the parsers are working, that the processes is working and whatnot. Okay, now let's go back from the server back to our OASIS. So this is our OASIS again. Yeah, and now I want to go into the actual section about schemas and ELNs. And for this, I will create this electronic lab notebook example here. Press the add button here. So the upload is appearing. It has a few files in it, like a few things are here detected and then processed. I will explain this in a bit. But first of all, it's the same functionality, right? You have all the processed entries here, all files that could be detected by Nomad are listed here, and then the respective database entries that were created. And then you can navigate to those. And here in the file browser, it's the same thing. Here you see all the files, like some of the files were detected by Nomad, other files are just auxiliary files that are there. And then again, you have the file browser to look at everything here. And with these files, and now that we are on our OASIS, we can switch back to the administrator kind of view and look at the files that we actually created in our OASIS installation right here in the volumes folder. You can now see how the files are organized. Like when people are creating uploads and they are not published, they are in the staging mode, everything gets a subdirectory in staging. So the uploads get a randomly created ID, and then based on this ID, you get these subfolders here, and this is where all the data of the upload goes. We always have the raw directory that contains all the uploaded files, so that's exactly the same files that you see here. So in this sense, this is more or less just a Dropbox of some sort, right? People can upload files and download files. You see them here, and then this is then what actually is not Dropbox anymore, is that we process all these files, right? And for those files that we detected and where our parsers will run, we create these archives, like in this message pack format that I was mentioning yesterday. But basically, it's just a binary form of JSON. Like we process everything, and then our archive format has this specific JSON flavor based on our schema, and then we store it like this. Okay, just as a side information. Like for the end users, that's not really irrelevant, but for the administrators, it might be interesting to know how this works. Okay, so what do we have here now in terms of files? So there's a README again that tries to explain a few things, but that's basically what I want to say anyways. So let's have a look. There are various files in this upload. Some of them are detected and some of them are not. So and those that are detected, they all say archive. So these are basically file formats that aren't really external or anything, though the files are already in the Nomad archive format, so they already have like the Nomad format. And this is just how our ELN works, right? So the ELN can be used to create these archive files directly from the GUI, and then we store those as files in this space here. So, but the idea is that you don't really create them manually, but you use this thing here below where you can create new entries with this drop-down menu. And here you can basically select what kind of entry you want to have, and here you can say what the entry should be called, and then it will be created here. So in the same way, like you can imagine that these things were created. And this, what you see here, is basically all the entries that are available. Though there's some entries that come from the Oasis themselves. These are all these that have Oasis in it. But these basically come with our installation. They are part of the Nomad software, so to speak. And these ones are customized ones. Like these are stuff that you created, so to speak, or that came with this example uploads. So if we look at the files again, we have lots of actual data files, and then we have this one schema file, and this is what we want to look at first. Like this one basically contained the schema for the ELN that we want to use in this example. So let's have a look at the schema. The schema itself behaves like a normal Nomad entry, like it gets the same view, right? You have the metadata about the entry here, and then you have some information about the entry there, and then you can look at the files that are attached to it, like the schema file. And the schema file basically has this YAML flavor that we talked about yesterday, and we can have a look at the details in a bit. But for right now, just see it's like a normal YAML file, and it has like these definitions in it, and then it defines like sections and so on and so forth. Later on, we will look in more detail into this and try to manipulate this a little bit to change how our ELN looks like and stuff like this. But for right now, just observe that there basically is a YAML file behind this. And what our system gets from this YAML file is like these definitions can be then seen in this data view, right? So this is the raw file view where we look at the raw data, and this is the data view where we look at what Nomad understood from this raw data. So here we see the definitions that are in the schema, and we see that we defined a few sections here. There's a section for chemicals, a section for instruments, a section for processes, a section for samples. And right now, let's look at the chemical first. That's a very, very straightforward one. So it's basically a normal section definitions. Definitions you always see is like in blue, like data is black and definitions are blue, so that you can get less confused, I hope. And here you see how we define the chemical. So basically it got the description. And you see here the descriptions, they can have all kinds of markup in it. So if you want to have like these complex explanations what your data means, you can put in like formulas and whatnot. And then this definition is pretty straightforward. It just defines a few quantities. There's a chemical formula, there's a name, there's a description, and so on. There's a form, like is it crystalline, is it powder, whatever. But this is really up to you, right? You are defining the schema. This is just an example. Like what eventually appears here is not my choosing, it's your choosing. Like someone in your group needs to be responsible for creating these schemas, modeling basically your research process and whatever you need to acquire your data. Yeah. Another interesting part about the schema is that we have some base sections. So there is a chemical base section that is not part of the schema itself, but that comes from Nomad. So we provide a few basic ideas, so to speak, a few base sections that you can use, that you can reuse. In the future, we want to extend this a bit so that you don't have to start from scratch when you're writing a schema, so that there is actually something that you can relate to, that you can reuse, and only have to extend it so to speak. So in this particular case, for example, the chemical formula, the name, the lab ID, description, that already comes from the space section. It's basically inherited. So this is not really part of the schema itself. And only these things are then customized. And if you look back at the YAML file here, unfortunately, my screen is super small. If we look at the chemical here, or let's download the file. Let's download the file and look at it in my tool here. If I jump back here, I downloaded it to here. So that's the YAML file from the server. Here's the chemical section that we defined, right? Under definitions sections, we have the chemical. And here we say also what the base sections are. This is how we say, okay, we want to have this existing one that comes from the Nomad sources. So that's basically Nomad package names and stuff like this. Here we use the existing base section chemical. And then stuff gets inherited, right? So the name and the formula and stuff like this, it's not really in here. Here we only define the form, where I was saying, okay, I want to have an enum with these values here. And the CAS number, the EC number, these are just defined as strings. And yesterday we already talked about annotations, right? Here we see these annotations where we say how we want to have this represented in the ELN. So I don't really want to explain all these kind of things here, though this is basically a blueprint for you, right? You can copy paste in here, you can change stuff and whatnot to help you to get acquainted with these. We can later have a view at the documentation and see like a little bit of the stuff is already put in the documentation so that you get some hints. Otherwise, I try to comment stuff in here so that you get an idea what these parts actually mean. But let's go back to the Nomad itself. So we were talking a lot about the schema now. Let's have a look at what the schema actually does for us. Like let's have a look at an actual entry, data entry. If I go back to my upload, we also have like other entries in here, like these, and these are actually data entries. And if you look at the process view, you also get the entry type here. This is then based on the schema. You see we have a few of these chemicals, right? So this is the section name that we just saw, the chemical section that we defined. And now if I click on one of those, we basically see all the stuff that was defined in the schema again, like the chemical formula, for example, the name, the lab ID, the description field. And then also the custom things that we defined, like the form, the CAS number, the EC number, and so on and so forth. So this information basically comes from the schema. And if you add stuff to the schema in the same way, you will get more form fields here, right? So that's the whole idea behind the schemas. And with the annotations, you can control how this actually appears, right? Here we use like simple text fields. Here we use like this rich text editor. And here, these are again text fields, or this enum thing gets this pull down thing, and so on and so forth. So this is what these annotations are doing for us, right? These annotations are basically telling the system what component to use to make it part of the EL and make it editable, and then use various quantities for this. So let me head back a few more explanations, and then we actually start to change the schema so that you see the effect of it. There is one more thing I wanted to talk about in the schema. First of all, you can always go to this data view. I hope these jumps are not too confusing for you, right? So we are on this overview page here. And when I click here, this button, I basically get automatically redirected to the data view, but directly on the section that I clicked on, right? So this is where you find the same chemical. It looks like exactly the same view. But now we are in this browser, and the browser gives us much more functionality to go from here to other stuff. For example, we can go to the definitions itself. So whenever you are confused, like you're looking at data and how it is defined, what is the corresponding schema to it, you can click on this definitions thing, and then below you will get a link to the definition itself. And now we are at the chemical definition. And this is where I said yesterday that things start getting confusing when you think about schemas, because everything has the same name, right? So this is our data section, and this is our schema. And here we can see them side by side again. The chemical formula is here, the name is there, the lab ID is there, and so on and so forth. And here you can also see that the annotations are different, right? So for the lab ID, for example, the ELN annotation just uses the string added quantity. And for the description, where we get this complex view, there it's like a rich text added quantity. And in our documentation, we have a link to an overview where you see all these various form fields that you can use for the various types of data. Yeah, so that's one point I want to mention. The other point that I wanted to mention is the other base class here. We have this entry database class. This is an empty base class. It doesn't really do anything for you. It's just a marker for the system to recognize what are actual top level sections, right? Because sections can only be subsections. They can also appear in different places and whatnot. With this entry data, you're basically saying, okay, this is something where I want to enable my users to create entries from. And then this is when you go back to upload, this is then what populates this, this thing here, the types, right? So these are all inheritance of this entry data section definitions. Here we see this, the chemical, for example, but the schema also defined other ones, like one for instruments and one for samples, so that people can decide whether they want to create data about a chemical or sample or an instrument. And again, these are just examples, right? You can call them whatever you want, whatever you need in your lab, and create whatever you want here. Okay, so when people want to create a new chemical, for example, right? I don't know what, they can just select this chemical thing, press add, and then they don't have this filled out, right? They get an empty one, but it's still based on the schema that we uploaded, and then they can start entering stuff in here and say, you can give a formula, whatever, and name this somehow, right? And save it, and then it's part of the system. Another thing that is worth mentioning with these base classes that we saw, like the chemical base class, let me head back to there. The definitions are still turned on. So like the chemical base class, it itself also has other base sections, right? So it goes a little bit deeper. We have this ELN with formula base section. We have this ELN base section. And this is where all these attributes come from. Like the formula comes from here, the name comes from here, and so on and so forth. And the idea about this, and this is also explained a little bit here in the section definitions, is that these things, these properties that are pre-configured, that we can add them to our search index. Like for the custom ones, it's really hard to make them searchable, right? But for the predefined one, it's very easy for us to put them into our search index and make them part of the search interface. So we put like the normal stuff in there, right? So typically you want to have a name for your stuff, you want to have a description for your things, and then you can have some text search on it. And then there's also this text mechanism that I want to explain in a second. Yeah, but this is basically then what gets into the search. Also the chemical formula, for example, right? We are taking the chemical formula, dissecting it into elements and stuff like this, and then also populating this in the search. So if I would jump to the search, let's say I go here to publish, you have two searches. You have to search for your own data that only shows the stuff that is visible to you. And then there's also the public search that when people on your Oasis said, okay, I'm done with my work, I want to publish everything, it will also appear here. So let's say I go here. I already see all the entries that I've created in here. Like when I have no search criteria selected, you basically get all the data that is available. And then here you have this view where you can create search criteria. I explained this in the first tutorial for the normal theory kind of data. And for these ELN-based sections, we created this electronic lab notebook section here, where we can provide a little bit of search functionality based on the properties defined in these base sections. So for example, you can search for the section itself. Let's say you want to see all the instances of the chemical section, right? And then you would get the chemicals and not get the processes and instruments and whatever anymore. So that's, for example, is one part. But then I also said that we are dissecting the chemical formula and putting this in the general elements and formula search that we have in Nomad, right? So the chemical elements that you're using in your formulas are appearing here and stuff like this. And the other thing I wanted to show is the text mechanism. Let me go back to Lab Notebook. When I select chemicals, though there's no text yet because we haven't defined any text yet, in our chemicals. But this is basically something that you can do in the schema. Like in the schema, you can decide my entry now should be allowed to have text, and you can also say what the text should be, or you leave it open so that users can use any strings as text. That then really depends on what you want to do. And yeah, maybe we try to do this. Let's try to extend the schema a little bit. I mean, I already downloaded it. So let's try to add a few quantities to the chemical just to make it somewhat interesting. Let's say we start with the text, and I really wanted to introduce text here. So I just define a quantity named text in my chemical section. And here I basically say I can define the type. Now I can either make it an enum and predefine what the possible text for chemicals are, or I just say, okay, I don't care. Users can do whatever they want. I know, and then I always have to put these ELN annotations to make it actually editable. We hope in the future that we can somehow simplify this. Like at the moment, it's a little bit weird that you have to type this anymore, because like mostly it's like kind of straightforward. Yeah, I have a string. Of course, I want to use the string edit component. Yeah, but maybe in the future we can simplify this so that there's a default and whatever, that you don't have to type this down anymore. At the moment, it's still a bit technical, and you always have to say what you want to have. So let's say we define this text thing, and texts are kind of special, right? The base classes are picking up, oh no, there's a text now in there, and then they treat this special and put this in the search index. But let's say we also want to add something else. Let's say we want to add, the safety sheet for our chemicals, where we want to upload files, for example. I mean, that's another piece of functionality, I guess. So in this case, we still treat it as a string. So what we are storing is actually the path to the file, but we have a special component for files that you can use to allow people to upload files. I think it's file edit quantity, I hope. Yeah, I think that's right. And then there's another annotation. And this is a little bit the tricky part, where I would say at the moment you will need these examples to get an idea what annotations exist. We are still lagging a little bit behind when it comes to documenting those. But I promise this will become better in the future. So I have one annotation that tells me I want to use the file editor to allow users to upload files at this point. And then there's another annotation that will allow you to actually make the file navigatable in your data, so that you don't just see the string of the file name, but you really can click on the file and go to the file and download the file and whatnot. So there's another one for this. So I always have to double check that I don't make mistakes. So let's see if I got everything wrong. Let's see what appears in the actual in the actual ELN once we upload this. So I save it here locally. Of course, now this is just on my disk. I still have to provide it to Nomad again. So I go back to my upload, and I can just upload this as a regular file, right? I can just use the upload button here, for example, and I just drop this file there again. Then it's processed again. And then it should be done. So basically, if I go back to my schema, where is it? This one here. It should look a bit different now. First of all, I can check if it processed correctly, if I did make any mistakes. So it looks good. There's no errors here. Like if I do a mistake in the file, there might be errors showing up here that hopefully explain to you what you have done wrong. So let's have a look whether our changes actually appear here. So I have the text thing now, and I have the safety sheet now, right? So these are the new things that we defined, have written down in the YAML. So let's see how this affects our chemicals. Let me go back to the upload and have a look at one of the chemicals again. So now they also should have the text in here, right? And they also have this safety sheet is missing, unfortunately. Okay, so then maybe I did something wrong there. So we have to revise this. But let's have a look at the text first. Yeah, we said this can be a normal string. I don't know, like let's call this project tag or whatever. I save it. So another thing that I'm not really happy with is like it's only one tag. I want to have multiple tags. So how can I do this? So that's another thing that we can fix. So I saved it, but let's go to the search and see if this tag thing actually worked. So there we have the project tag now, right? And the one chemical that it tagged with this is now actually getting the tag. So so that kind of worked, right? So let's have a look why the other thing didn't work. I probably did a stupid mistake. That's a little bit the hard part about the schema writing, right? Figuring out all the mistakes that you might made and stuff like this. So this is where we in the future want to provide at some point a schema editor, so that you really get a tool to create a schema and don't have to write this down, because this is a little bit like programming, right? You can make mistakes and then stuff doesn't really appear. Yeah, I think the mistake was that I did this annotations twice. It's one annotations section and then you have multiple annotations. So that's the first thing. And the other stuff that I wanted to fix is I want to have multiple tags, right? Not just one tag. So I have to define a shape and say I want to have a list. And this is how shapes work. You basically define the dimensions. You can do something like this, right? Or you can, like, if you just want to have an arbitrary dimension of arbitrary length, then you can just give a star and say, I just want to have a list of as many values as I want. Okay, these two fixes, let's see what happens. Let's go back to the upload. And upload the schema again. That's another reason why you want to have a schema editor, right? You don't want to have this writing something, uploading again, writing something, uploading again. And every time my browser gets a little bit smaller. Okay, so let's see if this is now better. Let's go back to chemical here. So let's see the text one. Oh, I got to a different chemical now. But let's see, now I can have multiple text, right? So this is how our list basically works. I basically every time I type something, I get one field more. And if I remove it, it's one less. So now we can have many tags. And the safety sheet is now also there. And here you see, like, we didn't use the string added quantity, we used this file added quantity. Now we can actually upload something. And this is where I had prepared the safety sheet here. So we can click here and it gets uploaded, right? You can't really see it here, but if you go to the files view, you see that in the same folder as our entry, we see that now the safety sheet, the uploaded file is also in here. And if we did everything correctly, it should also appear in the data browser. So if we go to our chemical and the sheet here, like in the browser, we can actually then navigate also to the file, right? We get this button here, and then we see the file and we get like the file preview and everything. And of course, you can download the files and whatnot. So yeah, so this is like how it basically works, right? What the relationship between the schema and the ELN is. And you also saw a little bit how you can manipulate the schema and add your own quantities to it. Yeah, and the idea behind this example is that this is for you like a starting point where you can take this as a rough sketch, right? And then iron it out and change stuff around, change the names of things, add new quantities, add new subsections, and so on and so forth. As a final thing, let's have a look at a more complex example. Right now, it was just the chemical kind of things, which are kind of boring because it's just one section and everything is in this one section. But I also have like a more complex example here where we actually look at like how you might want to structure a sample that you might deal with in the synthesis lab, where you create a sample, run different processes to create the sample, and then do some characterizations and whatnot. The overview is again the same. You get like the top level section here, and you can look at the rough stuff. But here we now have multiple sections, right? You also get subsections and things like this. You can decide in the schema what of these sections should appear on the overview page, and for everything else, it appears in the data browser here, right? Where you always get the full view of all the data, and where you then can really see the subsection structure. Like here we organize it that the sample is the root section, and then we get like a subsection for processes. And then I defined in the schema 2 processes, one like this and one like this, to showcase a few things. So one thing, for example, that is probably interesting is like you can also have like these number fields with unit support and stuff like this, and also automated unit conversion and things like this. So for example, I don't know, if I want to go from this to 100 Celsius, you can do something like this, but you have to know how to write Celsius. Yeah, something like this works, or you can just convert the units like this. And then depending on how you check this, the number changes or the number changes not. And all these kind of features that are more like for physicists, I would say, besides just having text and what else, you also have these date fields and so on and so forth. There's also one interesting annotation that you can use for light parsing, so to speak. You saw this in the example on the second tutorial where we had something similar. We have this where you can define a data file, and then you can upload this in the same way as it worked with the safety sheet. But now we upload here in this process, we upload like CSV files, like a normal comma separated value file. And then there's an annotation on this that makes this that makes the system parse it and fill out these properties based on the data that is found in the CSV file. So if I go on section definitions to have a look at this data file, like here in the data file, we use like this tabular parser annotation, which tells us first how to parse the CSV file. So it's in the background, it's using normal pandas to parse it. So you can give it a few parameters to say what is the separator. Like in this case, the CSV file uses tabs and what comments to ignore. Yeah, and then the different quantities down here that we have, like the Schema pressure and the substrate pressure, they also define an annotation tabular that gives the name of the column where to get these data from, right? And with these two annotations, the system knows that when you uploaded a file, that it should look at the CSV file and try to parse it and pull out the information and populate these things here. So we did this for the time, for the Schema pressure and the substrate temperature. And then when you click on this, you can even see a plot for this. And then the actual values that came out of the the actual values that came out of the CSV file are here as well. And if I go back to the annotation, the plot is another annotation, right, where we basically say we want to have a plot. The y-axis of the plot is supposed to be the substrate temperature, and the x-axis is supposed to be the time. Right here you see the time, and here the substrate temperature, and the information comes from these two quantities, and the information in these quantities actually came from the data file through the parsing annotation. Yeah, so that's a little bit of a more involved example that showcases how we can use like these annotations to more more effect. And we are continuously working on trying to improve this, right? Have more annotations that allow you to do more stuff like plotting and parsing and whatnot. Okay, I'm coming to the end for this part of the tutorial, and I heard a clicking, so there's probably something in the chat to look at. So let me do this right now. Okay, is there any questions about the ELN and schema stuff before I go answering the questions about the Docker Compose, which are popping up as well? Does anyone has a question for the schemas and how these work, or is interested in learn more about this, or should I go into some detail about the YAML file or whatnot?
Hey, Markus.
Hello, Sebastian.
Maybe I was too quick, but the linking from the CSV file and like the parsing, can you show me again? Was that also in the YAML file, like in the schema that
Yeah,
you
exactly.
provided?
Like all these annotations.
Yeah,
they are coming from the schema. So if I go back to the schema file,
yeah, I would like to see that highlighted, please.
Try to find this. So it is in the PVD. Where is it? Sample subsections. Yeah, subsections. Here's the PVD evaporation subsection. And here we see the annotations for the section, and then there are also annotations on the quantities themselves. So on the section, we have the plot annotation. No, this one is not functional. This is a feature. Let me remove this. This is a feature that we haven't implemented yet. That was just an idea to also have plots on the sections themselves, not just on the quantities. So let's ignore this one. But there is now the data file has an annotation for enabling the parser, so to speak. That's this one. That's just telling how to interpret the CSV file. And then the other ones, the Schema pressure and the substrate temperature, they have the annotations for actually defining from what column they are coming. You can also do some unit conversion in the annotation. Like here, I think the table is storing them in degrees Celsius, but we want to have them in Kelvin. So we basically tell that the table is storing them at degrees Celsius and we want to have them in Kelvin, then the system knows how to convert them. And then this is the plot one, right? Which just gives two axes. Like at the moment, the plot one is very simple. It only allows these XY axis line plots. Yeah, but we hope that we can, like, especially the plot one, I think we can make much better. And because in the end, it's just plotly plots, and it should be possible that a lot of the plotly configuration that many physicists are familiar with, right, could be part of the annotation and then just forward it there, that you can have more interesting and more complex plots.
Okay, and is it a CSV only or also Excel files? Or would you have to convert to Excel to CSV, for
I
example?
think this would also work for Excel files.
Okay.
So later
And-
we see an example. Later we see a different example where we actually parse an Excel file, but we use it not as a part of an ELN. We use it as a whole. So it's a little bit different, but it uses the same code. I'm pretty sure it should also work with an Excel file.
Okay.
Or if not, we make it work with an Excel file.
Okay.
Under the hood, it's the same pandas implementation that deals with
klar.
this, right, which is able to deal with Excel as well as CSV in the same interface, so to speak.
Okay. So you just have to make sure that the CSV file is pretty much clean, so that you don't have inconsistencies or run into errors.
Yeah, this we will also see in the next section of the tutorial when the Excel file actually has some problems. Yeah, but
okay, thank you.
Yeah.
Hi, Markus.
Yeah, hi.
Yeah. In this tabular parser, so can we pass in the YAML file as an argument the same arguments as for pandas?
So this here basically, this is passed on to pandas.
Yeah. So we could add additional pandas stuff.
Yeah, exactly. You could add additional panda stuff there. Yeah, that was the idea behind this. We are still lacking documentation on the annotation, though. What we have in the documentation, however, is when you go to this archive and meta info documentation, first of all, there's lots of explanation, what an archive is, what a schema is, and so on and so forth, like some of the pictures we saw yesterday. One thing that we have here is at least there's documentation for the different added components that you can use. So we have this overview page where you basically see the different form fields that we have, like the ones for strings and the one for numbers with the units and stuff like this, and like booleans and enums and different flavors and sliders and date fields and whatnot. And we put this little thing in here so that you can copy basically the annotations and know how to use these kind of things to make it a little bit easier. But this is only for the ELN annotation. Like for the other annotations, we still have to write the proper documentation and also like improve the features a lot, right? So it's pretty beta at the moment, I would say, but it already gives you something to play around with. Yeah.
Thank you.
Any more questions?
Yes, I have another question. This feature with plotting, etc., this looks pretty similar what these Nexus files has. Because there you also describes data, where to plot it, how to plot access, etc. Isn't it the kind of the same what you do here to implement? Wouldn't it then also be a way that you transfer first your files in a Nexus file and then import, then you have all the features?
Yeah, if you want to go through this and want to do this, like if you want to base your stuff on Nexus anyways, which I hope we will have another tutorial at some point, right, where we can actually show the Nexus features that we are implementing as well, then this pales in comparison, right? So if you really go through the trouble and really preparing a proper Nexus file, then this doesn't really be interesting anymore, right? Because then you could just use the Nexus viewer that we also have and go into more details there, right? So this is more like a Nexus-less approach, I would say, to do some plotting for all these cases where you don't have a Nexus file, right? People are not all the same. Not everyone thinks about Nexus the same way as some people think about it. Let's put it this way. And it also gives you a preview before you have the Nexus file, right? So right now we are working, when it comes to Nexus, we are working on different things, right? There's the idea of combining the editability that we have here with Nexus files, so that some of the Nexus file might come from an instrument or it comes from some machinery or whatever, and then other parts are added manually. And then in this combinatorial process, your result would probably be a Nexus file, right? And then you can use the visualization on the Nexus file and wouldn't need anything in here. But there are other ways where, let's say, where you want to start with something like this, and then at the very end you produce a Nexus file, and then maybe you need something in between where you want to have some plots and whatnot. Yeah, so it's, I mean, it's a difficult space. We are still figuring it out ourselves, right? What features to support and what various ways of maintaining the data we have. And Nexus is definitely an option that we want to offer, but it's not the only option that is there.
Okay, I just thought that creating these schema files and all this annotation is more like the same effort to write a parser for the to create these Nexus files and have the same feature.
So what we want to do in terms of the Nexus support is we want to align the schemas, hopefully so much that it doesn't really make a difference anymore, so that you could use the same schema to create an ELN like this, but also use it as the basis for your Nexus files. And then the integration would be much tighter, right? So then basically having an ELN entry like this and having the Nexus file would be the same thing. So you then could really consider this an editor for your Nexus files, so to speak. But we are not there yet. But that's a possible route where we want to go into, so that you don't have to define two schemas or something like this, right? You just define one schema and then you use it for Nexus as well as for Nomad.
Can I comment on that?
Mm-hmm.
I mean, at the end, it's the same process. Yeah, if you write down a schema and then you exchange this with your group or even with your community, you kind of define a standard, which can be like, if you make this very official, it can be even a Nexus standard. Then at the end, it's pretty much the same process. So this is why we encourage you to exchange with the people within FAIRmat on your schemas. So this is also the idea that Markus showed with the chemical, for example, that was already implemented, something that some part of the committee agreed on, and then people can reuse the stuff, and then it gets even more efficient using this kind of system.
Yeah, that's definitely like a long-term strategy, right? To base on these, to work on these base classes more. Exactly. Right now they're super technical, right? They're just to have something in the search index and to help you to organize your data. But eventually, ideally, this became something like a standard, or we connect this to a standard, right? So that these base classes are basically Nexus base classes or something that you might be able to use. Yeah, it's very interesting times that we are in with all these various formats and schemas and whatnot. But it's also a little bit like the problem, right? We can now create lots of schemas and have different ways of creating schemas. And at least we want to align a little bit the schema system, so that the Nexus schema and the Nomad schema becomes the same thing, and maybe even integrate this with more. I can make from the ontology space, there's lots of other things, or there are languages like LinkedML or JSON schema or whatnot, right? There are lots of schema systems out there. So that's one problem where stuff gets confusing. And then, of course, in the schemas itself, like everyone can now write their own schemas. And we try to find like a balance between incentivizing people and actually using these base classes, so that it's not too confusing and not too much customized stuff. But we also want to allow people to customize things, right? If you just provide fixed schemas, that's probably also not the answer, because every lab is different in a way. Or if you are innovating with new methods and stuff like this, you simply have no standard that you can adhere to. But with the Nexus community, there's at least a way to take your schemas and make them aware to the community, and there's a process where stuff might get official or less official, whatever. I think they have different stages of where your contributions can be. I think there can be contributed base classes and then official base classes and whatnot, or application definitions are they are called, sorry. Okay, if there are no more questions, I will go into the tabular example. Or looking at the time, I would say maybe we do the tabular example in the, no, it's just 1 hour, right? It's not 2 hours. We are 1 hour. No, okay, we still have time. So let's jump into the tabular example then. That will be much quicker than this one. All the complicated stuff about the schema we already figured out. I just wanted to show with the tabular example like a different way of entering data into Nomad, and this is when you, let's say, have data in tables and CSV files and Excel tables and whatnot. So we have this other example here. Let me add this to the system. So in this case, we have yeah, we have an exit table. I Googled through the internet, and I just took the first exit table about the periodic table that I could find, and used this as the basis for this example. So it's more like school physics, I guess, or chemistry. But I think it serves as a good example. It's rather simple, but I think everybody knows what the periodic table is and so on. So in terms of files, let's look at the files first. In terms of files, there's just two files, right? There's the schema file, that's this one. And then there's the exit table. And then there's a README, but ignore the README. There's the exit table and there's the schema file, and they both belong together. So they are named the same, and this is how the system knows that they belong together, that when the system looks at the exe file, it should also look at the schema to understand how to interpret the exe file. So these are connected. And then from this exe file, we get now many entries, right? That the exe file has, like, I think I have the exe file open here. It's a very basic kind of, you get the symbols and the element names and a few properties. I don't know if this table is correct or whatever. It's just something that came up. Yeah, and it has like these 100 whatever. You know better how many elements there are than me. So it basically created an entry for each of the rows in the table. And it's now the difference between this parsing and the parsing that we saw before. Before it was like we take the CSV file, and then we take the whole column and shove it into one property, like to create a large vector that we then can do plots over and whatnot. And here now it's different. Now we do this row by row parsing. And the idea is that many people organize their data like this, right? They have like these super large exit tables with lots of columns in them, and then they put their measurements or their experiments or their samples or whatever in these exit tables. And for those cases, when you want to put then stuff into Nomad, we are thinking about this exit parser, so to speak. So let's have a look at the schema first, and then we look at the entries. So the schema definition has just one element in it. Just one element called element in it. So my periodic table schema is kind of easy. It just has this one section definition in there. And in here, I just define, again, a name, description. And then here comes the stuff that really comes from the table, like the order number, the symbol, the group, the period, where it is in the periodic table. And then I also defined a subsection here for the properties, like, the basic things, like the density, the melt point, and what you might find in a table work about this. Yeah, and this is what it looks like in the schema. Annotation wise, let's have a look at the schema file. Let's download this as well. And have a look at the YAML. So in the YAML, it's the same thing. It's this one section kind of schema periodic table. For the base section, I now have to use this table row base section to enable this the table parsing, so to speak. And otherwise, these the different quantities also get this tabular kind of annotation, right? That tells them to draw stuff from the various columns of the exit table, right? So in the exit table, where's my exit? It's sim and element, right? And then in the schema, we basically use this to refer to the various columns. And this is then all that the system needs, right? This table row basically enables the table parsing. This base section allows me to, like, if I have something in name and description, to put this in the search index. Like for the name, I use the element column, and for the description, I use this, what's it called? It's called origin of name. I use this as a description, like this text here. Yeah, and then this is all that it's to it. And then if you upload this stuff, you get then the data like this, right? So the tabular parser is basically dissecting everything and putting it into different, what do you call it? Into different entries. And if I look at those, I get the information that comes from the various columns. And then it really depends on what the columns have in there. And this is where I said, now you can see what happens when the exit table has problems. So I get the information here. And if I go to properties, I also get all the properties in here, but this might not be complete, right? So if there's nothing in the table or a specific cell could not be passed because it was not a number, then something might be missing in here. And then the log view would show you where you would have troubles in your table. Okay, yeah, that's basically it about the table. Otherwise, the whole schema stuff is the same, right? If you change the schema, let's maybe we want to change something. For example, I just realized there's an error in there. I think I had heat capacity first, and then I wanted to rename it to specific heat, and instead I renamed it to specific capacity, which doesn't really make any sense. But the process would be the same, right? You go to the schema, you change your stuff. Where's this? Let's say this is specific heat. And then you re-upload this again. The problem now that I'm already anticipating is if I upload this again. So let's first let it go through the processing. If I go to the schema here, let's see whether my change was successful. So in properties, it's now specific heat, not specific capacity anymore. But the problem is that the data that we have in the system still uses specific capacity. So if I go to an entry here, I don't know, what was it before? This was it before, right? If I go here and go to the properties, the specific heat isn't really appearing. If I look at the data, it's still in the data as specific capacity, right? So I still got the old stuff. So it's really hard for us to decide when you upload a schema what needs to be changed, right? We don't really want to force everyone to process all the time and stuff like this. But if you have something like this, if you know that your schema changes will affect some of the data, we have like these reprocess buttons on the upload. Like if you go to your upload, you can press this one. And that's basically analyzing the exit table again, right? Or you re-upload the exit table. That would be, I guess, another solution for the problem. So it's parsing the exit table again, and it's producing all these entries. And then the thing should be appearing again. So if I click on this Bismuth again, now it should be reappear. Let me see, properties. Oh, the specific heat is there with the new name of the column. Yeah, so this is how this basically works. For some reason, I decided to define these things as ELN sections, but it doesn't really make sense, or that's the limitation of the system. The table parser isn't really part of the ELN, right? You can't change this. This is yeah, I think we still have to work on this. That should not be editable and stuff like this, because right now we can't be we don't write the exit table again or something like this. Right? It's not Excel what we have here. It's just a way of importing the data, so to speak. Yeah, but this is what I wanted to show. Like in principle, it's now possible that you take larger legacy data or whatever that you have in exit tables, write a schema for this exit table, and then upload them both together. And then you can basically get the data into the system like this. This, for example, is interesting because you can use this in combination with your ELNs, right? Let's say you have all the chemicals in your lab or all the samples in your lab organized in a table. You can upload them like this, create a database of all your chemicals, so to speak. And then when you define whatever processes that you're doing where you want to reference chemicals, samples, whatnot, you can then reference them based on these uploaded stuff. Okay, I think that this is what I wanted to show. So it's now again up to you to ask me questions about it. or give me general feedback about this whole thing. I hope that this helps a little bit to explain how this whole schema system works and how ELNs are happening. And this is really, I guess, a difference in approach to other ELNs, where typically ELNs, they're either already made for a specific method, right? And then you don't have to define a schema, or they are just note-taking tools where you can't define a schema. And the Nomad approach here really is about being fair data, right? Having a schema for everything, having everything well defined. And this is why in the Nomad ELN, you basically have to write these schemas, but this gives you the ability to basically cut this directly for your various experiments, for your various labs, groups, and whatnot. Yeah, and with this YAML file process, you get a chance to basically do this yourself without having to change the Nomad software behind it. Yeah, but we know that this process is hard. It's not easy, even with the YAML files. And this is why we have in FAIRmat this domain expert approach. And a lot of you are already in contact with domain experts from us, and we really want to help you to develop your things together. And then hopefully in the further developments, I mean, FAIRmat is still running for the next 5 years at least. We can further refine this and then even make this easier, for example, with a schema editor and stuff like this, with more support for Excel, for Nexus and so on. There is one question: could we make this example accessible somewhere? First of all, people can just go to the public Nomad and just create these examples for themselves, right? So everyone who creates a Nomad account can basically go there and have this. On your Oasis, you could publish these uploads, right? If you want to. There is this, like right now, I think I explained this in the first tutorial. I haven't really got into this super much. But on your uploads, you have this kind of thing to share your upload with other people. Where you can basically invite more co-authors or reviewers that give people write and read access to your uploads. That's one thing. And the other thing is you can basically publish your upload, which makes it read only for you, but available for everyone else. And this is something where I guess we have to build in more features for the Oasis. I think I even write down something like this in future versions of Nomad, that this will be different. Right now, there's no way in the Oasis to keep it editable and make it visible to everyone. So you basically would need to go there and add all the users. But I could imagine that at some point we have something where we say, okay, I want to have this to be a public project or a private project where you basically make it visible to everyone or not visible to everyone. And then, of course, we also have to figure out what publish actually means, right? How to communicate this from your Oasis to maybe a central system where it's actually published and stuff like this. So this is the work in progress. We have a tutorial in summer, which hopefully then will be about these kind of things. Yeah, right now I can only say this is like future work for us. But of course, you can make Oasis publicly available to everyone, right? And then people can log into your Oasis, create these examples by themselves, or you can start sharing your uploads with certain people. And then they can also log into your Oasis and actually see these uploads.
Yeah, I was also wondering that, but actually my question was about that you showed this example with the Excel file and the YAML file. Is this, can I download this somewhere, this example, or is this just?
So
like
yeah. So once you created the example like this, like this tabular data, you can press this button to download the whole thing. Like you would get basically.
Okay, it's
basically get these files.
Preset, it's in the preset examples. Like.
Yeah. So this is for all the uploads. You always get the download button.
Yeah.
And then for individual files, like if you just want to have the Excel file, you also get the download button always here. So in this sense, you can download everything. Yeah. So data management, like these are the core functionality, right? You can upload data, you can download data, like this the Dropbox functionality that you kind of always.
Because I just didn't follow that this was actually one of the upload examples, because in the version 1.0, so it's I think not yet
Yeah,
there.
yeah.
So, and I had some issues with the 1.1 right now, and so it's,
Yeah, okay.
I
So
was just following.
this button comes with 1.1.
Yeah. Okay.
So are there any more questions?
I have a question.
Yes. Yeah.
So now you implemented support for CSV files like within a schema, and this Excel thing that you just showed now for if you have like a database or something. What about data that is already structured? Like if some users have, for example, JSON files or YAML files, how would we do this? Or could this be directly be imported?
Yeah, this depends on how their JSON files look like, right? So if I go back to the first example with the ELN, this one, the files that the Nomad uses, right? Like the chemical files, for example, that we create with the ELN, they themselves are just JSON files, right? They just look like this. So I don't think it will work out of the box, but basically, if the information is available in the same form as the schema is, right, then that should be possible. It's just a few technical things that need to be added, like this here, for example. But otherwise, it should work, right? That there might be some light modification that you need to
this
do.
kind of data, and
yeah.
So if you can make a kind of, then we don't have to write a schema for them. We can just then modify.
Yeah, exactly. But this is the thing, right? For Nomad to work, everything needs to be in the data section. And then for the data section, you have to define what schema class you are using. And then comes the actual data. But if you have the actual data already in this JSON form and you can make this compatible enough in your schema, then it's pretty simple. And you just have to do a very mild transformation on your JSON data. And then you could upload this like this, right?
I have some people in mind, they have exactly this type of data. So
you can even put the data in the schema in the same file if you want to. You can just write one YAML file, have a bit of schema and then a bit of data in there, and then just upload this. Like if you have a very simple case where someone just want to publish something, right, that is super specific. We had this, for example, with these quantum computing guys, right? They're inventing these algorithms, and then they wanted to publish some data about it. And of course, we didn't have the schema for it. They just had one entry, right? They simulated something for hydrogen or something. I don't know. With this now, they could basically just define their schema and then put their data into the same file, upload it, and then it would be there. Yeah. So these YAML files, right? They have this definition section, but in principle, they could, after the definition section, they could also have a data section, and then basically have the actual data that is happening in here. They just would need to say, okay, I want to use this element section definition that I just defined here on top, right? And then they could go about and say whatever is defined in the schema. And then you could upload this thing. I mean, I can even try this. I can just create a new upload. So something I haven't practiced before. So let's see what happens.
It's just because I have like several users. They have files like this. So then it would be no problem to do this.
So let's see. It didn't work. I don't know. Let's see if we can figure out what I did wrong. But now you see the logs view and what it looks like if there's an error. Name. He says attribute name does not exist, right? I thought name was defined. Is a name defined? What did I do wrong? It's the data section. I say I want to have an element. Interesting. In principle, it works. There's an example in the source code that you can look at that actually works. And maybe I do a stupid mistake here, and it needs to be a bit different.
Yeah, you can just point me to it later.
Yeah. Give it one more try without the name. I don't know why he's stumbling upon the name. Yeah, but this is how it could work in principle, right? If your JSON files, you just have to put. Yeah, I can't get it to work. Anyhow, yeah, I'm interested what I'm doing wrong. Maybe it's the table annotations that are setting him off or something like this. Because now I don't really want to have a table and stuff like this, right? But it shouldn't be. I don't know. I can tell you later how to do this properly.
Thank you.
Yeah, that was not part of the tutorial. We just were looking at Excel tables and stuff. Yeah. Yeah, so in this sense, the ELN is just an editor for these files, right? And if you have these files created by some other capacity, you can also upload them. Okay, any more questions?
I have a general question.
Yeah.
Is there any way to keep track of the version of the schema? Actually,
Yeah, that's another thing that we have to work on. Like for example, right now when I upload, if I would upload, like here for example, I get these from the schema, right? If I would upload the schema twice, I would get this twice, and it would not be the same schema, right? So every uploaded schema is basically its own schema, and if you upload it twice in like slightly changed versions and slightly changed variations, you would basically have two versions of the same schema in there somehow, right? In the data, everything is like linked together, right? If I look at let me go back to my examples. If I go in this example here, for example, so I have my schema file here, like I have my schema file here and I have my sample data there. And if I look in here, if I go to the raw file view and see how the JSON actually looks like, you see this reference here, right? So it basically points at a certain schema. It says in the same upload, I want to go for this schema. So if I would upload another schema and call this like schema 2 or something like this, even though it contains the same thing in a slightly different version, it wouldn't really interfere with this one because this one is still pointing at this file. So you wouldn't have a problem. In this way, you could basically, in principle, support multiple versions, but you would confuse yourself, right, if everything has the same name. So there needs to be some version metadata, I guess. And the other problem is like if you change this one without changing the data, then you also might run into trouble, right? There's no check. That's not checking like this. I want to have this in this version or whatnot. So what we plan to do is to have like a hash for schemas that could act as a version so that you can actually make a check and see this data was really made for this version of the schema and not for a different version of the schema. And this will also be very important for us when we have stuff on the central server and even when we want to have stuff long-term, because schemas just change. It's just part of the life, I guess. And then you have data that is referring to older versions of the same thing and other data that's referring to newer versions. And we need to have the system for this. And version numbers could be one thing, but I guess we have to go for something that is more technical, like hashes in addition to version numbers, for example. And then we could really make sure that something is trying to reference the right schema, not the wrong schema.
Thank you.
Maximilian asks, I have a general question about Nomad, if I may. Which is the best way to programmatically access Nomad Python? There is the normal client, the possibility to use the request package, and the Optimate package. Which one do you recommend, and what are the plans for Optimate support? Yeah, I mean, both are valid kind of ways of using it, and it really depends on the use case, right? If you use the request package, you get the most low-level access to our API, and I guess the least problems, but also the least comfort, as you are basically directly talking to the API, right? Otherwise, I would recommend the normal client. Like we have this PyPy library, the archive query thing, but this only supports like a very narrow application where it's about like doing a search and mass downloading like certain parts of the archives for these entries. Like if you have this, then I guess the client library is the right way to do. The Optimate API is like helps you in, like it has this Optimate query language, like it might help you in finding certain calculations. But otherwise, the problem is the Optimate API. It only gives you a very brief overview of the entry, right? It doesn't really give you all the metadata that we have, but only what's defined in the Optimate standard. And then there are a few other things that we might put in, but these are the mostly links to where you can get to the actual Nomad API, where you get more information. And then you are basically back to using the request library again on the Nomad API. Otherwise, the support for Nomad is for Optimate is we plan to continue to support it, and then the question is what the Optimate community comes up with, like in the future. So there are plans to extend this towards, like there's lots of discussions about ontologies, about molecular dynamics, and stuff like this. Yeah, but the Optimate community is moving much slower, I would say, when it comes to experiments and synthesis data and stuff like this. Andreas asked, people are still trying to get their Oasis running and running into troubles. One is a permission denied on the files. That's interesting. Like maybe a little bit of background information. So the Nomad containers, like the Nomad app and the Nomad worker, they are all using the user 1000 group 1000, right? They use user ID 1000 and group ID 1000. And then it depends a little bit on this volume directory, whether it's already existing. And I don't know exactly what permission it gets. And it's also different from system to system. Like on macOS, it's different than from Linux, how host mounts are actually treated in terms of file permissions. But hopefully with the information that all the files need to be inside the container, need to be readable from user 1000, you might be able to fix this, like the volumes folder, the FS folder, give it to user 1000, for example, or change the read-write permissions accordingly so that user 1000 can actually access this.
Okay, this might be the reason. It's by default created by the app, but then it gets permission only for root.
Okay.
So I checked with the other permissions. Thank you.
Yeah. And maybe it's safer than to create the directory first yourself. I don't know. I'm a little confused that Docker Compose is able to create root directories. Or is it Docker? Is it who is creating those, right? If the host mount point is not existing.
It's probably Docker, and Docker needs some root permission.
Okay, then maybe we should refine the installation routine at this point a little bit, and maybe make sure that the volumes directory gets created first with the right permissions before Docker is creating just something. Yeah, but if the like inside the container, the mounted volumes directory eventually has to be read-writable by user 1000. That's the technical answer, I guess.
Sorry about the same. So the user 1000 is the user of the Nomad Oasis inside, or because it's just, is it by accident that it's my user ID at the moment?
So the images are built in a way that they default to user 1000. And if you haven't written down anything else in the Docker Compose, I think they should then also be run at user 1000. Could you Docker exec into these containers and just run ID or something to see what users they are run at?
It didn't. Now it started, but the changed permissions. I was just confused because my user ID is 1000.
Okay.
There is some coincidence or some additional problem, but it works if I change the.
Yeah. So if you look at the screen share, I hope you see this. Like if you ask for the ID inside of the that is used to run the app within the container, it should be 1000. So the app basically runs as user 1000 and needs then be able to access the files accordingly. So if you go in there and then the volumes container is the volumes is mounted here. So they should belong to the Nomad user, which is like 1000, 1000.
Yeah.
And if this gets mounted differently and it's not like this, then you might get problems.
With the change ownership, now everything works, and I could also connect to the app.
Okay.
Web. So now everything seems to be fine.
Okay, cool.
Thank you very much.
So if there aren't any more questions, I would say we almost took the whole 4 hours, 2 hours anyways. So the idea now is I basically leave you alone with all this information and with things to try and whatnot. And in the evening, I will be here for questions and answers. So if you encounter any problems or have questions or whatnot, I will be tuning in at 4 o'clock again, 1600. And then you could ask more questions or problems that you run into, we could discuss and whatnot. Otherwise, there won't be any real program again. We recorded this session. We will put this up on YouTube. So like if you have colleagues or whatever who's interested in, they could also have a look. The same about the talks yesterday. They will also be made available. And then we link everything on the tutorial homepage once this is done. Okay, then thank you very yeah.
Well, maybe I can just ask one more question. Like, can you transfer the YAML schema once you have written this and it works? Can you generate the Python code from that? And then maybe if you need like more fancy stuff for a normalizer function, for example,
Not,
and then this...
not yet.
Okay.
Yeah.
Okay. Thank you.
I mean, we could build something like this if this is like a real use case, but it's not yet there.
Okay.
What you can do, however, is you can use this in a Python world, right? You can load the YAML and make it basically Python classes, but not the code of the Python class. If we really want to have the source code of the Python class, then we have to develop something to. Yeah, but I know what you mean, right? You start with a schema, right? And then you want to, like the tabular parsing isn't doing for you. You want to have some more complex parser, for example, that you want to put in there, and then you need to go into the Python world again. Another thing that we might want to do is have some Python plugins that people can provide themselves and then use those plugins in their YAML schemas. So I could imagine that the whoever is controlling the Oasis installation has some control over what software is running, right? So we could mount a plugin directory, so to speak, where the Oasis admin can put some Python code that does something, like, and then maybe this Python code provides additional annotations for specific parsing tasks or whatever, and then you could use those in your YAML files. But then those would only be available on the Oasis, right? Because like even if we would have a connection between a central installation and the Oasis installation, we would not copy the Python code over. We only copy the YAML stuff.
Thank you.
But also for custom parsers and stuff like this, like some kind of plugin mechanism could be a good idea, because then people don't necessarily have to like make this. And this also, we don't at some point don't want to have this anymore, right? That anyone asks like, oh, I have something, put it into your project, I guess with a plugin mechanism, everything could be more scalable. Because I anticipate in the future, people will have much more of these little parsers that they want to have. Right?
Thank you.
Okay, then let's see you again at 4 o'clock if you're interested. I will be there in any case. So have fun with this information, try stuff, and then see you. Bye-bye.